to get started. Hi, everyone. My name is Vilko. I work at the foundation as a grant program manager for Divinity. I used to be a full stack developer at an analytics company, programming in Java and JavaScript, but I couldn't pass the chance to work at the foundation as I've been following the project for a while, but more on that later. So my talk will be about the ICP ledger. I think everybody here knows what the ICP ledger is, but just a quick overview. The ICP ledger maintains a list of accounts with ICP balances. It enables you to transact ICP, and it maintains a history of all past transactions. But the most important thing is that it's just a canister, just like the ones that you have been building. There's no special, it doesn't get extra memory or extra compute. It works just the same as the canister that you have been building. The only difference is that it's written in Rust. So if you look at the source code, it might look a bit unfamiliar to you compared to Motoko, but in the end, this compiles down to WebAssembly, just like your canisters. What makes the ledger special is, of course, what it's used for. You need to burn ICP to get cycles for your canisters, which are needed for storage and computation. You can lock ICP up in a neuron in the NNS to vote on governance proposals for the IC. It is minted as voting rewards to neurons in the NNS, and it is also minted as rewards for node providers. So one thing that is confusing about the ledger is the difference between a principal ID and your account identifier. So I first wanted to get that done. If you're using Plug and you open your account details, you see this principal ID string, which has these hyphens in there, and the account ID, which is just a bunch of numbers and letters. And the principal ID is, you can see it's sort of like a public key. It's directly mapped to a private key. One private key equals one principal ID. And your principal is used to identify calls to and within the internet computer. It's not just used for the ledger, but it's used for any call that you make. So if we take this very small Motoko program, you see that a public shared function has this message, and if you return the message.caller, that is the principal ID of the person who, or canister, who has called this function on your canister. If we call this from the Motoko playground, by deploying this, this might be a bit slow. In case it is, I've included the screenshot here. If we call this whoami function from Motoko playground, you get this principal, which you'll notice is a lot shorter than the one in your Plug wallet or when you use DFX, and that is because this is the anonymous principal. This is used whenever you're not logged in, whenever you don't make the call from Plug or DFX or internet identity, but if you just call it from a browser without being logged in. So one private key maps to your principal ID, which you use to sign messages on the internet computer. If you use the DFX identity command, if you do DFX new, let's say bootcamp identity, then it's creating a new identity. What that means is that it's generating a new private key, which maps to a new principal ID. If you then do DFX identity use bootcamp identity, it will switch to using that private key and that principal ID. And if you run the command DFX identity get principal, it will print out your current principal ID. I see there's a question in the chat. Is the anonymous principal the same as the zero address? the zero address is a special address in the ledger that is used for minting and burning. But the anonymous principal ID is something else. Now, a ledger address is derived from your principal ID, and one principal ID can have many ledger addresses attached to it, because a ledger address is created by combining a principal ID with a sub-account identifier, and this is a 30-byte string, 32-byte string, which can be anything. So you can make as many ledger addresses as many combinations you can make with 32 bytes, and that is basically an infinite amount of ledger addresses. When you combine your principal with a sub-account identifier, you get this account identifier, which is a 28-byte string, and the final ledger address is the account identifier plus some redundancy, which creates this 32-byte string, and I'll explain that in a bit. So to get the account identifier, you take the hash of the principal and the sub-account identifier with this string in front of it. For those who don't know what a hash is a function that gives you a random output based on the input. But if you put in the same input, you will always get the same random output. But if you change just one byte to the input, you get a completely different random output. So anytime you put a different principal or sub account identifier in this hash function, you will get a completely different account identifier. And the account, how you calculate the ledger address from the account identifier is by putting a CRC32 checksum in front of it. And that's just, that's pretty simple actually. It's just a string. This string is created from your account identifier. And let's say that you fill in your account, your ledger address somewhere, and you accidentally change this A to a C, then this checksum won't be correct anymore. And when you then try to send a transaction, it will fail because the checksum is incorrect. So this is just to protect from accidental mistakes. Because obviously, if you accidentally change the ledger address, then you won't be able to access your ICP anymore. DFX has a command to calculate a ledger address called DFX ledger account ID. You can give the principal and this sub-account identifier, and it will calculate the ledger address from there. And if you just do DFX ledger account ID without anything, it will use your current principal ID and the default sub-account identifier of 32 zeros. So some concepts for how the ledger works internally. You have 3 different operations: a transfer operation from one account to another, a minting operation, which is from the minting address to a ledger address, and a burn operation, which is from a ledger address to the minting account. Operations are put into a transaction together with a memo, which is just a number, which you can you can use anything for that. You can use that to add some business logic to your transaction, and they're created at time, which is not the time that the is not necessarily the time that the transaction is included in a block, but can also be the time that you created the transaction, for instance, with DFX. A block includes one transaction per block, And besides the transaction, it contains the parent hash, the hash of the previous block, and the timestamp when the block has been created. And the entirety of the ledger is this, these blocks that are chained together through this parent hash. So that's why it's called a blockchain. You have a block that refers to a previous block, and that block refers to the block before that. And so all these blocks with all these transactions are linked together. So for Motoko developer, the ledger, the two most important functions on the ledger are the transfer function, which allows you to make a mint or transfer or burn transaction, and the account balance, which gives you the current ICP balance of an address. So the transfer function has the following parameters. The amount of ICP for the transfer, and this is in E8S. If you look at the source code from canisters from the foundation, you will often find this E8S at the end, which is basically means that you have to multiply the number times 10 to the power minus 8. So one ICP is a 1 with 8 zeros, ICP E8S. The fee for the transfer, the from sub account. So this is an optional parameter, and if you maybe already forgotten, this sub account identifier, the 32 byte string that is combined with your principal ID to get the ledger address. If you don't specify this from sub account, it will just take 32 0. The memo is just this number you can include. It can be anything. The to address, so this is the ledger address that the transfer has to go to. This is without the checksum, without that CRC32 in front of it, so 28 bytes. And the created at timestamp, which is optional. So a special address, which was mentioned in the chat earlier, is just this 32 zeros. This is the address that is used for minting and burning ICP. If you mint it, it comes from this address, and if you burn it, it is sent to that address. So for a normal transfer, not a minting transfer or burning transfer, the following preconditions hold. So you have to own the source account. This is checked by using the account identifier function, which takes the caller, which is your principal ID, which I just showed with that Motoko whoami function, the one who calls the transfer function, and that is combined with the optional from sub account parameter to give the source account. And only if you have the principal ID, you can so you can only get this source account if you have the right principal ID that is the caller of this function. For a normal transfer function, the fee always has to be this 0.0001 ICP. If you use a different fee amount, the transfer will fill. The created at time parameter has to be not too far in the past, less than a day, and not too far in the future, only 1 minute compared to the canister time. It checks if there are no duplicate transactions, so you don't actually accidentally send the same transaction twice. And of course, the source account has to have the right amount of ICP in it. The result is pretty obvious. This transaction of type transfer with the memo and created at time is added in a block to the ledger, and the balance information is updated. For a minting transaction, the preconditions is that the caller is the governance canister, the NNS. Only the NNS can mint new ICP, and from sub account, that optional parameter has to be null, the default 32 zeros. And the result is, yeah, pretty obvious. You get a new transaction added to the ledger, and the balance information is updated. For burning, the preconditions is that the to address is the minting account address. The fee has to be 0, but the amount for a burning transaction has to be more than the standard fee. And the result is again that the ICP is burned and the balance information is updated. The other function is a lot more simple. It's just you give an account identifier and it will give you the current ICP balance for that account in this E8S notation. So other functions that are on the ICP ledger that you don't really need for the ICP ledger, but can be useful for when you deploy your own token is the name, which is the name of the token, the symbol of the token, the transfer fee, how much that is. You can update that when you deploy your own ledger, and how many decimals the token goes to. Then there are also functions that don't have a candid interface yet. So I won't go too deeply into that because this is a Motoko Bootcamp and it's hard to call these functions from a Motoko canister, but it's you have the tip of the chain function, which will give you the latest block plus some proof that can be falsified. And there's a function called block, which will give you the block at a specific height. If you do want to use these functions from Motoko canister, then Quint has made this nice little repo, which is a Rust canister, which calls, so then you have this in-between canister, which calls the ledger canister for you. And then this does have this ledger, this candid interface, which means you can easily use it from a Motoko canister. Yeah, one important other thing to mention about how the canister works is that blocks are archived because, as I said before, the ICP ledger canister is not special in any way. It has the same limitations. It is restricted to 4 gigabytes of memory and 8 gigabytes of stable memory. So if you would use just one canister, then at some point the canister would become full and you couldn't add any more transaction to it. So and even if you had more memory, which canisters might have in the future, then you also have the problem that if you want to upgrade the canister, you have to put all your data into stable memory and then from stable memory back into your normal memory. And that can cost a lot of cycles if you have a lot of data and you have a limited amount of cycles that you can use in an upgrade. So it could be that if you want to put too much memory in stable memory, too much data in stable memory for an upgrade, then that can fail because you use too many cycles and then your canister is stuck forever. And that's something you have to take care of when you're developing canisters yourself as well. So what the ledger canister does is it maintains the last 1,000 till 2,000 transactions in memory, and then every 1,000 transactions it sends the oldest thousands to an archive canister. And when that archive canister reaches about 1 gigabyte, I believe, then a new archive canister is created and all the transactions, all transactions are sent to that new archive canister. So if you want to interact, if you want your application to interact with the ledger canister, you probably want to deploy a local version because, yeah, archive canister is fast blocks, correct? The question in the chat. So if we keep updating a stable variable, will it ultimately out of memory as well? So the updating of the stable variable doesn't really cause an out of memory. For instance, if you have a stable variable, which is just a counter, and you upgrade the canister, then the only thing it has to put into stable memory is that single counter. And then when the upgrade is complete, it will load that counter back in. But let's say your canister has an array of bytes, and you keep adding bytes till it reaches like 3.5 gigabytes or something like that. If you then put it into stable memory and have to load it back in, you can run into issues. Yes, those were the questions. So if you want to deploy a canister, you probably want to deploy a canister locally, because if you're going to test with an actual real canister, then if you make a mistake, you can lose ICP and you have to pay the transaction fee every time you test it. So you can build it yourself from scratch, but as I said at the beginning, it's written in Rust. So if you want to build this canister yourself, then you have to install some Rust tooling. And that can be annoying if you never worked with it. So what the foundation has done, it has created a tutorial here where you can download the WASM of the canister, so you don't have to build it yourself. And then in this Ledger local setup, it contains instructions for how to deploy this local version of the Ledger canister, which you can then experiment with. I'm not gonna walk through it entirely, but here you download the WASM, here you edit your DFX to contain the Ledger canister, and then here are some further instructions from how to deploy this locally. The ledger is the blockchain on ICP. Is that correct? What makes ICP infinitely scalable without running into scalability problems that other blockchain faces? I will get to that to the end, but basically what makes it scalable is that it doesn't have to save all the past blocks. The ledger canister does this the reason it does this is because this is pretty important for something like a ledger canister, but as you may have noticed in your own projects, you don't have access to all the old state of your canister. So you only have to keep track of the current state on ICP instead of something like Ethereum, where you need all the past blocks to get to the current block. So that is, so you can use these two links to deploy the canister locally. And what you then probably want to do is letting your canister hold ICP, because that is the reason I think at least the blockchain is interesting. You can do all sorts of things that you can do with a traditional system. You can create a DAO where only if a certain amount of people vote, you can make a transaction, like the NNS is a DAO, or you can make a DeFi contract where you can swap ICP tokens for different tokens. And one great starting point for letting your canister hold ICP is again this repo by Quint. So let's quickly walk through it. So if we look at this Motoko file, you see that this actor takes an argument, which is the principal of the ledger canister. If you would deploy this on the IC, you would use the principal ID of the ledger canister here, but if you deploy it locally, you can use the canister ID of your locally deployed canister. And you see that the creator of this canister is the owner. And it has this balance function, which calls the ledger and gives you the current balance of this canister. And you have this transfer function, which transfers an amount of ICP from the address of this canister. And you see that you have this assert caller is owner here at the beginning. So that means only the principal ID that created this canister can actually call this transfer functions. But you could do a lot more interesting stuff here. You could make this function not public and have like a public vote function where you vote for a transfer, and only if the transfer gets enough votes, then you actually execute it, or any business logic that you would want to include. I would, if you want to experiment with your canister holding ICP and sending ICP, I would deploy a local ledger canister and then deploy this ICP canister and then experiment from there. Is the ledger available as some base library? I don't think, no, I don't think it is. But you can, use this repo to see what you need to do. So one thing, a common use case is that you want to verify that somebody made payments for your service or NFT or token. And the ledger canister is a bit limited there because with the account balance function, you can verify that a certain address holds how many ICP that address holds, but you can't see who made the transaction. So if you want to Andres, I'll get to that question in a bit, Andres. So the foundation made an invoice canister, which allows you to do this. It allows you to create an invoice and then make sure that the person you sent the invoice to has actually paid you an amount of ICP. And how it does this is by, if we go to the design doc, how it does this is it creates a different address for every payment. So as I said before, with one principal ID, you can create an infinite amount of, almost infinite amount of ledger addresses. And what the invoice canister does, zoom in. So what the invoice canister does is it creates an invoice, and this invoice result has so this invoice object has a destination, which is an account identifier. And when you transfer your ICP to that specific account identifier, then the invoice can be verified with verified invoice. So this way, any payment that the users of your service make will go to a different account, and then that way the payment can be verified. Andrew says the invoice canister deploys a ledger canister itself. Why is that? For local deployment? Yes, this is indeed for. This is the ledger WASM I was talking about earlier. So this is just to test the invoice canister locally. It's this is basically what you get when you follow the instructions in this ledger local setup. Instead of following these instructions, you can also clone the invoice canister, and then it will already contain this WASM and the ID file, and you can just run this. There's the build script, I believe. Or you can just use DFX to build this with a local ledger canister. Andrew says, thanks. So if we wanted to call it on mainnet, we would just need to import it with what specific syntax. So I believe I think the ledger is given as an argument somewhere here, but I'll get back to that question later. But you don't have to import it with specific syntax. You can just create an actor. Oops. You can create an actor with a candidate with candidate types and a principal, and then you can call that actor in your Motoko code. Maybe I can look up an example of that later. One other thing I wanted to discuss is the Rosetta API /node. The Rosetta API is an open standard for querying blockchains that was created by Coinbase, and Coinbase had the problem that lots of different blockchains use different standards or different mechanisms to come to consensus, and it was a lot of work to integrate with all these blockchains, all these different architectures. So what they made is the Rosetta API, and if your blockchain implements this Rosetta API, you can very easily integrate with exchanges. The ledger canister implements this API, so that means that if you use the ledger canister for your own token, but with a different name and a different, if you deploy your own token with a modified ledger canister, then you automatically get this Rosetta API in your canister. So this is also very useful for if you want to communicate with the ledger from outside the IC. So if you're running some centralized infrastructure on AWS and you want to query the ledger, then you can run a Rosetta node, which is this Docker image that the foundation provides, and you can use this Rosetta API to query the ICP blockchain. So this would be useful, for instance, if you make something like a block explorer for the internet computer or anything else that you want to query the ledger canister from the outside. Additional resources for understanding the ICP ledger would be the community conversation from Bogdan, one of the creators of the ICP ledger. It's what I use myself as well to get a nice understanding of the ledger. And another one is ICP on canisters by Roman, who also worked on the ICP ledger. And this was made when ICP on canisters was enabled. So I would check those two talks out if you want to learn more. Finally, I want to tell something about the DFINITY grant programs. So we have 2 grant programs at the moment: developer grants and community grants. The developer grant is for code, we fund dapps and tools and libraries. And we have 3 tiers, 5K, 25K, and 100K. We don't often start with 100K, like you need to be a decent sized project to immediately get 100K, but we often start with a 5K or 25K and go from there. And you can apply for anything that is useful to the broader IC community. You don't have to develop a full-fledged application. It can also be a tool or library. Make sure you define some clear technical milestones in your application. And if you want additional tips for writing the grants, you can check out this Medium article, how to write a perfect developer grant application. And if you want to apply, you can go to dfinity.org/grants. The community grant program is for building community, obviously. The Motoko Bootcamp is actually a receiver of a community grant as well. It's for if you want to hold online and offline events, if you want to produce some learning materials, some editorial stuff like blog posts or articles about the IC. And when you apply, make sure to emphasize on how this will be good for the community, the IC community as a whole. Sometimes we see applications where people are only focused on how this will benefit their own project, but make sure this is community grant. How will it be good for the entire community? You can find tips for the grant here, similar to the developer grant article. We have a Medium article for the community awards program as well. And you can apply at dfinity.org/community. Yeah, the PowerPoint will be available to be downloaded. And that was it. Are there any questions? I see Andres has raised his hand. I don't know how to give him access to talk.
You should be able to.
Hello. So basically, I just have a question. So if we wanted to build, some kind of fungible token on the computer right now, like for example, the test token for, the projects that Stopa did, we will have to basically get, like clone the ledger canister, like make it like make a ledger canister for that token.
Yeah, you can use the ledger canister. It's one of the options. You don't have to use it. There are other token standards like DIP20. I would research which token standard fits your needs the most. One advantage of using the ledger canister is that you have this Rosetta API included, so it will be easy for exchanges to integrate with it. But it could be that you miss out on some nice features that a token standard gives, like interoperability with other tokens or things like that. But yeah, if you want to deploy your own token, you would have to deploy a new canister.
Okay. By the way, I have like many questions, but if other people have it, like please tell them first. So I don't like, spend like 10 minutes asking myself.
If people want, I don't see any other raised hands at the moment. If other people have questions, please press the raise hand button. So I see Harsh has a question as well.
So my question is regarding the transfer functions. So suppose I have created my own token, let's say on dip 20. So which point exactly are we deciding which token to transfer? Because I don't find that in the arguments, like which of the tokens is being transferred with the function.
So that, well, it's the token is deployed, it's just the canister. So if you want to transfer another token that uses the same code as the ledger canister, you just call the canister ID of the token that you want to transfer.
So is it not possible to have, let's say, both ICP as well as our native token on the same method?
So you want two tokens in one canister, you mean?
No, just if, for example, I will give you the use case. Like suppose I am allowing payment either in ICP or my native token. So would it be possible in a single method?
You want to enable two payment methods.
Yes.
Yeah, I mean, you could just in your front end, when you select the token that you want to pay with, you can choose the principal ID based on that, and then make the call to the correct canister based on which token the person wants to pay with. So that's certainly possible. But that wouldn't really be at the canister level. That would just be for the client to determine the correct principal ID of the canister of the token canister that you want to pay with.
Okay, thanks.
Go ahead, Andres.
I'm sorry. It's just that I have like so many questions. But basically, in the invoice canister, I'm seeing like Kyle, he deploys like the ledger canister, and that's for like local deployment. But so if we're like on mainnet and we have like a smart, canister, one like to connect it to the ledger, how will we import it? How will we connect with it? Hello.
Oh, I think he got disconnected.
Yeah, maybe his internet or something.
Yeah. Maybe we should wait. Probably we'll come back.
Yeah, for sure. It's okay.
Yeah, power fell out.
Oh, he ran out of battery, I think.
Sorry, everyone. My other laptop power was fell out. Can you repeat the question?
Yeah, for sure. So basically on the invoice canister, Kyle, he deploys the ledger canister, for local deployment, right? And he like on the main mo file of his invoice canister, he imports it. How will we do that on mainnet?
So you can import a canister by its principal ID. I actually have a good example in the Motoko playground code. Let me share it in the chat. So if you Motoko playground surface. So if you go to the Motoko playground code, you can see that it has this. It needs to create canisters, and so it imports the management canister, and you can use the same method to import any other canister that you want to. Just define the interface, and then in your Motoko code you say, I want to import this canister which I know has this interface, and that's how you can import another canister and its candidate interface, and then call it like that. Let me see. I think it's in pool. So if you go to here, you can see. See the import IC type from IC. And then you see that the ICPSquad is a module which contains an actor which has all the calls from the management canister. So if you want to interact.
I'm sorry for interrupting, but I think you're not sharing your screen.
Oh, no, that's correct. I shared it in the chat.
Oh.
But yeah, I should share my screen. That makes way more sense. Because I'm on a different laptop, I can't share it now. Sorry. I have to give Zoom permission first. But if you click on the link that I just sent in the chat, I send it to host and panelist. Sorry for all the technical mishaps, everyone. So if you go to this link, you can see that it on the top you see import IC type from IC, and then if you go to ICPSquad, you see that you define an actor on the bottom, which is the IC management canister, and you can do the same thing for the ledger canister. So you just define an actor with the interface of the ledger canister, and then you can use that actor to make calls to it.
Okay, I finally get it, man. Thank you a lot.
Awesome, thanks. Does anybody else has questions? Ellie?
Yeah, hi, thank you very much for your presentation. So I would like to understand a little bit better. So the IC you said there is not everything that is always available, and that's what makes it scalable more than other blockchain. So and I guess for the ICP transaction, it's not the case, or is that correct? And so what makes it called a blockchain then if we cannot review all past transactions? Or
Yeah, so there are two things that make the IC scalable. The first is that you can add subnets, additional subnets, which makes it scale horizontally. So if I add a new subnet, I just get more storage and more compute because those subnets work in parallel. And the other thing that makes the IC just capable of handling far more transactions and compute power, and makes it so that you can store a gigabyte for like $5 a year, is that it doesn't save every old block. It just it would be a bit much for me to explain the whole chain key cryptography here, but Ethereum, every historic block is saved because you need the previous block to make sure that the next block is correct. But due to some smart people at Dfinity, you can disregard old blocks with the internet computer and just have this catch-up package for in case consensus goes wrong, and then you can catch up from that catch-up package. So that means that all the blocks before the last catch-up package can be disregarded. The reason that the ICP ledger works the way it does is because for transactions, it was just very important to keep the entire history for regulatory reasons as well. So that's why they sort of built a blockchain within a blockchain for the ICP ledger. But you can also implement a token which doesn't save the old transaction. You could also just implement the ledger and not the blocks and the archive canister. It's not necessary. It's just what has been done for the ICP ledger.
Oh, thank you very much.
Never understood why you can't just get rid of very old blocks on Ethereum as well. Well, Ethereum has consensus of the longest chain is the current actual chain, but to figure out which what is the longest chain, you need to go back all those previous blocks and check all those hashes to see if you actually got a chain that is correct. So that's why you need all the old blocks from Ethereum, I believe. Can we say that chain key cryptography works like recursive CK snark on other chains? I have to be honest, I'm not that deep into the cryptography aspect of it. I know generally how the IC scales, but I'm not deep into the cryptography of it all. Ellie, did you have another question?
No, it's okay. Oh, I mean, I would have many more questions, but thank you very much. It's good. Thank you.
I also want to say, everybody feel free to ping me on Discord after this. And in general, also, if you have questions about the grants program, or if you just have some piece while you're coding that is not in any of the documentation, I'll gladly act as a bridge between the engineers at Dfinity through Slack and Discord, because yeah, we're all benefiting if you can program at a quick pace.
Well, thank you very much for the presentation.
Yeah, sorry that my laptop fell out. That was a bit.
No worry. All right, everyone. Next presentation is in 5 hours. It's about writing canisters in TypeScript or JavaScript. So see you there, and have a good day, everyone.